Hello, Algebra 2 Honors kids. I have a review for you. This should help you with almost everything on your test. So if there's stuff that you're really stuck on, you can drop me an email, but I'll probably just send you to this review because I looked through the whole test when I made this. Okay, so first thing I want to talk about is types of functions. Okay, first of all, what is a polynomial? Remember, polynomials are like x to a number. It's like a number, x to a number. But that number has to be a natural number, a positive integer, plus or minus a number x to a smaller number. Okay, so like this guy is a polynomial. It follows that pattern, as is this guy. Now this is not, because polynomials are not logarithms. They're not logs. They're not square roots. They're not absolute values. What else are they not? They're not 1 over x. You can't have a denominator. You can't have a negative exponent. All these things are not polynomials. So this is a logarithm. This is a polynomial. It's actually a quadratic. This is a cubic polynomial. This one you would have to clean up first. It'd be 2x minus 8 plus 7. That is linear, so that is a polynomial. This guy, it's not an exponential. This is an exponential. Remember, exponentials show up if you looked at a table as like going times 2, times 2, times 2. Their rate of change would grow very fast. Now, logarithms, if you remember, you would pick the y values. The y values would be real nice. And then the x values would jump around. These would jump around. These would not be 1, 2, 3, 4. So almost all these tables say 1, 2, 3, 4, 5. But if it's a log, that wouldn't be nice because they spread out really far. Okay, now when you're given a table and trying to figure out what type of polynomial you have, you first make sure that it's not exponential. And look here, this one is exponential. This is a times 2, times 2, times 2. That's what that rate of change is. So this is actually exponential. Now, this one is a plus 3, plus 3, plus 3. So that means that it's a constant rate of change, and that is linear. This guy is plus 6. Then what do we have here? Plus 9, plus 12, plus 15. That's not constant. The first difference is not constant. In fact, this looks like a line because then the second difference is constant. So we call that, since the second difference is constant, we call that quadratic. It has a linear rate of change. And this one goes plus 6, plus 18, plus 30, plus 45. And then it's plus 12. I don't know what it says. 18 and 30, so what's that, 22? And then let's do, Miss Bruno can't see this very well. Let's do minuses here. 105 minus 60 is what, 45? 30, that's what I did wrong. 18 and 9. So then what do you have here? You have 15, 12, and 9. And then you have 3 and 3, okay? So this is not constant. In fact, this is what we call quadratic. This is linear, and this is the constant. So that means the third difference is constant. Since the third difference is constant, that means it is cubic, degree 3. Okay, so that's how you can tell for tables. Moving on, we're going to note these are polynomials first. Let's check these. Is this a polynomial? Yep, 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 yep. They're all polynomials, okay? Now, this is a degree 5. The highest exponent is the degree. The y-intercept comes from the constant. And now this idea of end behavior, and some of you said you were a little confused on this, okay? Here's what I will tell you about end behavior. You write it like this every time. As x goes to negative infinity, f of x, which is the same thing as y, where is it going? Well, just do a little sketch. What's a degree 5? A degree 5 is a positive snake baby. And basically, this is your x-axis and this is your y-axis. So x goes to negative infinity. Basically, this says as x is going to the left, if the graph is going to the left, where is the y going? Is it going up or down? It's going down to negative infinity. So as x goes to the left, negative infinity, y is going down to negative infinity. As x goes to positive infinity, which is the right, where is y going? It's going up to positive infinity as well. Okay, now this guy is always increasing. It increases the whole time. So this guy is always increasing. It's just a little extra question for you. Okay, now this guy, the y-intercept is 0, negative 15. I get that from the constant. The degree is 4, which means it's positive. It's going to be a U-shaped graph. Won't look exactly like that, but ballpark. So this one, as x goes to the left, where is the y going? As this graph goes to the left, where is this going? It's going up. Up is positive infinity. As x goes to the right, positive infinity, little glitcher. Where is the y going? It is also going up to positive infinity. Oh, sad. This one is degree 9, which is a negative snake baby. It's a negative snake baby. So it's going to be like this. Okay, I'm going to actually write the end behavior up here so that I have space. Y-intercept's actually going to be 0, 0, because there's no constant here. Oh, I didn't do this one on the increasing, decreasing. This guy, because it was a U-shape, it decreases and then increases. Sorry. So it's not always increasing or always decreasing, it turns. This one, what do I have here? Blah, blah, blah. And actually, I could have been wrong here. If you would have looked at the sketch, I bet it goes like this. I bet this increases and decreases when you look at the graph. You don't look at the sketch when you do increasing, decreasing. The question on the test is pretty easy. It is, you'll know what those graphs look like without your calculator, but make sure you take a look. Okay, end behavior. So if it is a negative snake baby, as x goes to negative infinity, the left, where's the y going? It's going up. And as x goes to the right, the y is going down. Basically, up means positive, and negative infinity is down. This guy is degree 2. Y-intercept is 0, 4. 5x squared is a U-shaped graph. It's actually parabola. And as x goes to negative infinity or the left, this graph is going up to positive infinity. And as x goes to the right, this graph is going up. Okay. These two. I just want to talk about end behavior here because these are tricky. Okay. So as x goes to infinity, and you have to write that out, as x goes to, or do you want to do negative infinity first? We'll do negative infinity first. As x goes to negative infinity, where is this graph going? It's kind of going down, but does it go down to negative infinity? No, there is an asymptote here. It's actually going to 0. It will never get there, but it's going to 0. Now, as x goes to positive infinity, the right, it is going up, up, up forever to positive infinity. Okay. The last one here, as x goes to negative infinity, as this graph goes to the left, where is this y value going? It's going to that asymptote of 0. As x goes to the right, to positive infinity, this guy is still on its way to 0. It won't go any further than 0. Okay, let's talk, we'll stop this and then we'll do this in parts.